Last year, in Statistics 1, you learned about the binomial distribution, and now you know how to operate with it. So you know that all you need to know the parameters of the binomial distribution are n, the size of the sample, and p, the probability. And it's very simple to work with this if n and p, they are small numbers. But what happens if n gets too big and p gets too small? Then you'll have to start operating with big numbers and very small numbers, which is more prone to mistakes. Luckily, the Poisson distribution can be handy in these circumstances because you can approximate the binomial distribution when n is very big and p is very small to the Poisson distribution. What are the conditions? So n has to be large, typically bigger than 50. P needs to be small, that is, the event must be rare. And the product of NP is not too large, typically smaller than 5. If these criteria are met, particularly if NP is not bigger than 20, in which case you cannot use this approximation at all. So if this criteria is met, then you may use the Poisson distribution with parameter lambda, in which lambda is what? Is just a product of NP. All right? As you are going to see, if you are in a course, if you are not, again, if you are watching this on YouTube, you have every so often this text going scrolling up that asks you if you want to just enroll in a course. Is completely free. But as I was saying, if you are there, then you are going to look at a bunch of questions that explains how this can be used. It compares the approximation with the actual binomial distribution. I can give you a glimpse of that over here. Okay, it compares the binomial distribution with the approximation using the Poisson, and what happens as the value of n increases and the value of p decreases, and how the approximation becomes more and more faithful to the real one, the binomial one. Okay, so go ahead. If you are not enrolled yet, it's completely free. Go there and you'll have access to all of this. But in terms of what you need to know for the Poisson approximation to the binomial distribution, this is it. Then you just deal with the Poisson distribution the same way as you dealt until now.